In this video, we are going to review Rolle's theorem. So, Rolle's theorem states that if a function is, number one, continuous on a closed interval, and I'm going to call that interval AB, meaning continuous from where x is A to where x is B. And number two, differentiable on the open interval. So differentiable between the endpoints where x is A and x is B, meaning no cusps, no corners, no vertical tangent lines. And number three, if the y values of the endpoints are equal. So f of A equals f of B. If these three conditions are met, then I'll write it formally and then I'll explain it. For some x value between A and B, for some c value in this interval, the derivative equals 0. So if a function is continuous on a closed interval and differentiable on an open interval, and if f of A equals f of B, if the y values of the endpoints are equal, then there's some point between where x is A and x is B where the derivative is 0 or the slope of the tangent line is 0. Okay, so let's look at an example. Let's look at f of x equals the cosine of 2x, and let's look at the interval from where x is 0 to where x is 2 pi. Okay, so first I'm going to consider each condition. Condition 1, is cosine continuous? Yes. Cosine is continuous for all real numbers. The domain of cosine 2x is all real numbers. So continuous on all real numbers, which definitely means it's continuous from 0 to 2 pi. Is cosine differentiable on all real numbers? Yes. The derivative of cosine is negative sine, and sine exists for all real numbers. So this is also differentiable on all real numbers, and that definitely includes the interval that we need it to include, which would be the open interval from 0 to 2 pi. And condition number 3, f of 0 is the cosine of 0, which is 1. F of 2 pi is the cosine of 4 pi, which is also 1. So, check f of 0 equals f of 2 pi. So, my three conditions have been met. 1, 2, 3. And now I'm going to find the value or values. There could be more than one answer where the derivative equals 0 between 0 and 2 pi. All right, so first let's take the derivative of cosine x. So first I'm going to say the derivative of cosine x is negative sine 2x times the derivative of 2x, which is 2, or negative 2 sine 2x. And I want to set that equal to 0 and solve for x. I can divide both sides by -2, which is just going to give me sine 2x is 0. I'm going to move the sine over to the other side, which is going to give me an inverse sine function. 2x is the angle whose sine is 0. The principal value is 0. The angle whose sine is 0 is 0. Okay, so if you remember, the general solution for sine is principal value 0 plus 2 pi n. 0 plus 2 pi n. And the second equation for the general solution for sine is pi minus the principal value plus 2 pi n. Now, it's not necessary to combine these, but it can simplify things a little bit. The first equation gives me 0, 2 pi, 4 pi, 6 pi, all of the even multiples of 2 pi. The second equation gives me pi, 3 pi, 5 pi, all of the odd multiples of 2 pi. So I can just combine those into every multiple of pi. So pi n. I'm going to divide everything by 2 now. And I'm going to get that the derivative is 0 for every multiple of pi over 2. Every integer multiple of pi over 2. So, what are the values that I want? Well, we're only looking at positive numbers because we're only looking from 0 to 2 pi. So, when n is 0, I get 0. Now, remember that my values have to be between 0 and 2 pi. So 0 is not actually going to be one of my answers because that is an endpoint, and I'm looking for x values between the two endpoints. Then I'm going to get pi over 2. When n is 2, I get pi. When n is 3, I get 3 pi over 2. When n is 4, I get 2 pi. And so on. That's my upper limit. That is also an endpoint, so I'm not going to count that answer. So my three values are pi over 2, pi, and 3 pi over 2. C is often a variable that's used in textbooks to identify the value that we're talking about. If you recall in the definition up here, I said for some C value, it's just a variable, between A and B, the derivative of C is 0. Okay, so we have our C values. I'm going to draw a quick illustration to show what we just found. So, we were talking about the graph of cosine 2x. The 2x in cosine 2x means that there are going to be 2 cycles in 2 pi. So we can draw our 2 cycles with a maximum of 1 and a minimum of -1. I will draw on my critical points to make it a little bit easier to be neat. There we go. Okay, and so the graph is going to look like this, and like this, and like this. Okay, there is our graph of cosine of 2x from 0 to 2 pi. And now it's easy to see where the points are where the derivative is 0. Remember that if the derivative is 0, the tangent line is horizontal. So, pi over 2, right there, horizontal tangent line. Pi, right there, horizontal tangent line. and right here, 3 pi over 2, horizontal tangent line. So the derivative at pi over 2 equals 0. The derivative at pi equals 0. And the derivative at 3 pi over 2 equals 0. So there's our example illustrating how to apply Rolle's theorem to a function that is continuous on a closed interval and differentiable on the open interval, and whose endpoints have the same y value. Again, in this case, the endpoints are where x is 0 and x is 2 pi, and the y value is 1.